Hello and welcome to Section 2, Unit 3 of Manufacturing 101 Blueprint. We are going to take a couple minutes and you will be receiving a handout in here to work through on your own as well. I'm going to take a couple minutes and go through this handout. A lot of it's going to be a repeat of Section 2, Unit 2, and that's fractions. But now we're going to be applying them to reading in the actual measurement setup. Okay? So real quick, this is a breakdown of a 1-inch block. Okay, there are 2 halves within the whole. And then naturally you have 4 quarters, 8 parts to a whole for 1/8 of an inch, and then 1/16 as well. So in Section 2, Unit 2, we broke down on the side of the board over here, we went from 1 inch, we broke it into half, and then half again, and half again, and half again. If you notice, same thing. 2 1/16 are in 1/8. 2 1/8 are in 1/4. 2 quarters are in 1/2. 2 halves are in 1 whole. Okay, same thing. Do not get overwhelmed by all of this. Very simple. The denominator, the bottom section, that's how many parts it makes to make up an entire section. Okay? So 2 1/16 is the same as 1 1/8. So forth. We talked about that in the beginning sections of fraction. So as you're going through this handout, the good thing about this, you'll notice, is the top section was empty. So I want you to work through it. So, you need to know this stuff just off the top of your head, the best you can. Okay? We've always got time to work on things. But here's a good example. That's what this class is about. It's the beginning steps. Okay? This is one of the first courses you're going to take in the manufacturing program. We have to start out somewhere. Some people are going to know this fairly well. Some people will not. Some people have never been exposed to it whatsoever. We cannot assume, and we don't want to assume. We're here to help people learn and better their skill set and further their education and job placement as well. Okay, so work through them, and then down here at the bottom, you'll actually have the answers to where you can self-check things on your own. Okay. So here's the same thing we had before, but now we just have it broke down into an actual inch measurement. Okay, so this is 1 whole inch. So real quick, this is half. This is half, okay? This is a quarter, 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 quarter. 8, 8, 8, 8, so forth. Then we break it down into 16. So the increments within it, this is the largest notch, then the next smallest notch. In this case, the quarters are the same as your half. Not most tape measures are not this way. Okay. When you get into precision measurement, yes, they are. They're usually, a lot of them are fairly close. You don't see a big difference, but reading a normal tape measure, one is going to be higher, and the next one's lower, 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 and lower, like the rest of this. Okay, so you've got one part, 1/8 of an inch, 1/16, the next one. So then the next one down would be 1/32. The next set here would be 1/64. So there's 2 64ths to 1/32, 2 32nds, 1/16, 2 1/16 sections to 1/8, 2 1/8 sections to 1/4, 2 quarters to 1/2. 2 halves to 1 inch. Okay? So as you come down through here as well, I want you to pull this measurement. Look at this. Find the measurement. Helps you along, tells you the numbers there on the bottom. Try not to just look at the numbers. Cover them up and move through it. Okay? We get back to converting proper fractions. Okay? 1 5/16. 20 1/2. You can get this handout from us, or it might be on the blackboard. Either way, we will get it to you so you can practice and make sure that you're proficient. Now here at the end, there is a review of mathematics and plane figures. You can revert to this as you're going through these questions as well. It gives you formulas, talks about square root, gives you how to define the area. The main thing I want to talk about here is here's a different formula, okay? The other one we've seen was pi r squared, correct? Here's a different way of figuring it out. You can also take the diameter, 7.854 times diameter, or this times diameter squared, right? No, it's not the same. You have to make sure that you follow this 3 setup. If you do diameter squared, that means that you're doing these two functions first, and then multiplying it to this. You cannot do that. You'll end up with different values, okay? Make sure you're 7.854 times the diameter to start with, times the diameter again, okay? Certain numbers, it will end up the same. Oddball numbers, it does not end up the same, okay? Gives you formulas, talking about volume. And you're not necessarily going to have to know the factors for figuring out the amount of liquid in a partially filled tank. But again, just kind of exposing you to some of the stuff out there, for sure. This matters sometimes when you are, hauling stuff up and down the road. If you have a medium in there, whether it's liquid or something else, you'll need to know specific gravity to start with and what the weight is per pound or square foot or cubic foot. I'm sorry, not square, but cubic. From that point on, then you need to start looking at this. This also matters when you're doing lifting, like rigging, where you want to put your load points, where you want to pick and rig to so that you can suspend this item with a crane or with a forklift as well. Think about where the liquid's going to shift. Get you thinking in those manners as well. Material forklift, handling, and so forth. So just a good example of some of the things that you might use within the trade, not necessarily in this class. Okay, so we're going to take 1 second here. Section 2, Unit 3 is going to be a fairly fast chapter. We covered a little bit in Section 2, Unit 2, about squares and so forth. So it'll be somewhat of a catch-up as well. All right. So going through. Introduction, tools for measuring distances, angles, other dimensions, specified print sizes. Dimensions on prints have tolerances, the amounts of allowable variation. Okay? Going to read from the book. Anything I read from the book, I would suggest highlighting as well. Introduction. Performing machining operations is only one part of a career in the machining field. Measurement is another core duty that is performed many times every day in the industry. During machining, dimensions or specified print sizes must be measured to be sure they are within required specifications. Every dimension shown on a print is given a certain amount of allowable variation. That allowable variation is called a tolerance. A tolerance gives a size range that's acceptable. Why do tolerances exist? They are an engineer's or designer's way of saying so long as this print dimension is within this range, the machine part will function correctly. Tolerances will be discussed in detail throughout other portions, mainly manufacturing 1. You should be talking more and more about them. We're going to break into them a little bit with GD and T as we go through blueprint here as well, okay? So let's move over. What is precision? Semi-precision measurement. Reading off the PowerPoint now. Measurement where tolerances, levels of desired accuracy are within 1/64th or 1/100th of an inch, 0.5 millimeters, or 1 degree. Always treat measuring instruments with care. Rulers. I would read through the rules section on page 84. I'm going to read just a little quick blurb out of the top of it. It says, the rule is by far the most common semi-precision measuring tool utilized in the machining field. It's a flat piece of steel with graduations that divide inches or millimeters into fractional parts. Rules are often incorrectly called scales. Everyone working in the industry needs to be able to read and use different types of rules. And that is just 100% one of the most important things I can stress about everything in this program. Even, doing the physical portion of welding, you're not measuring as you're welding. However, your end product needs to be within a tolerance of, say, a 1/4 inch fillet weld. We're going to have to measure it. We're going to have to understand what a 1/4 inch is, okay? Laying it out, cutting, pipe fitting, and the welding, it's used all the time. The fabrication industry, you'll spend more time measuring and doing layout than you actually do welding. And it's really important to be very accurate, be able to understand your angles, your functionality around your math, and how to use different formulas, and just reading the tape measure in general in squares, whether it's in machining, welding, electrical, industrial maintenance. A lot of that, a lot of the trades are going to require you, number one thing, understand how to measure. This is one thing you should walk out of here with knowing very, very, very well, okay? So here's a picture. What it's showing here is it's showing different sections. This is a hook rule. So there's a stop here on the end to where he can butt up against it. Otherwise, as you're looking down here, sometimes you have a tendency to favor one side more than the other. Okay? It gives you a standard point at all times. Now, one of the things you need to be aware of, if it's a very critical measurement, a normal tape measure is usually not accurate enough. Okay? If you notice, the end of the tape measure has a little riveted stop on the end. Well, I've had some tape measures for 10, 12 years. And I've had others for like 10, 12 days before they've got ruined. So, naturally, the ones that I've had for 10 or 12 years have a lot more play on the end stop piece at the end of the tape measure than the ones that are new. So it might account for a 1/16th of an inch here, but if you measure 4 different pieces at 1/16th, now you're up to about a 1/4 of an inch difference in tolerance, okay? Math and measurement compound upon each other. So if you make a mistake measuring this spot here, then everything else after that is usually off as well. So it's very important to go back, double check your measurements, stay and start from one point and work your direction either one in 2 different directions, whether it be your x-axis or your y-axis, either one, okay? Here are some small rules that can be used in tight spaces. This becomes very important, like if you're doing the inside of a bore, maybe a keyed slot as well. As you can see, here's the 30 seconds. The overall piece is a 38 or 3/8 of an inch wide, broke down into 30 seconds of an inch. Okay. Here real quick on this, as we can see, we're measuring here, so we have a 1 inch piece, so right in the middle is a 1/2 inch. Okay. Now if you notice how many it is broke down into 16ths. So 16, that number 16 means that there's 16 divisions in that 1 inch. So real quick, if we were to count them, we have 1, 2, 3, 4, 5, 6, 7, 8 16ths. 8 goes into 16 twice. So that right there is your half-inch mark, 8 16ths. I don't know that we can see this one really well. It's kind of fuzzy. See if I can get over here and see it any better. So this is a 100th scale. Okay? So out of all these pieces, for example, this is 10. On this side is the 10, and this side is 100. So you notice that they're broke down into sections 1, right? So this is 1/10 of an inch. There's our 1 inch. There's 1/10 of an inch. Now in here, in between this and 1, there are 10 additional steps. So in this case, we're 2. We are halfway between the 2 and 3. Okay? So we are at 10, 20. Halfway in between is 25 out of 100. So 1/4 of an inch. Now if it was down, we would count, we'd go to 2, and we were 3 little marks in between, then that would be 23 out of 100ths of an inch. Okay? So we can see on this one, our large number to start with is 4. And then it looks like we're broke down into 32nds of an inch. Looking back here, we see the 28 to the left hand of the 4, and then there's 3 marks in between, so 4 divisions, so we're at 32. So in this case, we're at 12, 13, 14. 4 and 14 32nds. Okay? Breaking that down even further, that would be 7 16ths. Okay? Take 32, divide it by half. It's a 16. You take 14 and divide it by 2. It's 7. 7 16ths. Go to this section here. 4, 14 16ths. Absolutely. And if what it's trying to show you here is how easier it is to see when it's held tight against it. You can see that division versus over here. It's hard to tell exactly, and then especially if you're coming at it from an angle, you might measure that as 14.5 out of 30 seconds. And what you need to do is make sure that you come back, hold the measurement, the rule flat, so that you can get a very accurate reading. Okay, this one right here, what we're talking about, aligning a measurement is easier than right here. Okay, so remember we talked about the hook. We talked about having that hook to catch it. Now if it doesn't have a hook, so for example a square has a hook as well. So if we're measuring this, we can hook on here and make sure it's nice and snug, right? But we have this hook. Say we're measuring just a flat ruler. It's really hard to decide if we're a 16th off, and I know I'm being very drastic here, but if we're 16th over here or 16th here, we're going to start to compound. So what this is showing is that we bring it to the 1 inch mark, we bury 1 inch, it's what we call burying an inch to make sure we're even, and then we make our measurement. So say we end up over here at 21.5 inches, we also need to come back, make sure we subtract that 1 inch from that 21.5, so we're at 20.5 inches, true measurement. This is where it becomes tricky. You have to remember, if you use and align it to a 1 inch standard, to make sure that you deduct that from it, okay? If you get in the habit of burying 1 inch, it becomes a lot easier. It becomes repetitive. If you are constantly going from 1 to 2 to 3, then it sometimes gets a little trickier on the math portion. This one looks fairly aligned, however, it's not always the case. So real quick, I want to go and talk about graduations. Not your college graduation. Out of the book here, I want you to find the definition for graduation. It says graduations are the divisions or spaces on a rule. So that's the parts of an inch, correct? So right here we're talking about the different graduations, whether it's on a metric or an English, it does not matter. Okay, these are both English rules. This is more of your traditional, what you would see with the tape measure. So these are broken into 8 divisions. This is 7 of the 8. This is into 16ths. If you notice, these two are aligned. So this is 2 16ths is 1/8. Again, this is 1, 1, 2, 3 16ths, 4, 5, 6 16ths, which is also, if you're looking at the larger scale numbers, 1/8, 2/8, 3/8. Okay? 9 16ths, 15 16ths. These are in graduations of 1/8, and then naturally this one and the 3/4 are just reduced fractions. Okay? Now when we look over here to the right, let's take a look. I want you to notice, excuse me, that this rule has 2 different divisions on it. Look right there in the center, the 16 and the 32. So that means the top section is is in a different increment of graduations than the bottom. So really quick, I see that, and I can see that exactly halfway between the 8 and the 9. So if I'm at 16, then the top section must be a 32nd scaled rule, and the bottom section must be a 64th scaled rule. So same thing here at 8 and 1/32. We are 1/32 to the right. We get over here, we're 1 below the 8, the 7, 11. Jump down to the bottom. It can be the same thing. Okay? All right. So these are in 1/2 millimeter increments on this one. We're down into the metric system. Okay. So here's 10 millimeters, but it is broke down into 1/2 increments. So if you count them, there are 20. Instead of 10, there are 20 individual ones. Walks you through it. So 0.5, 1, 1.5, 2, 2.53, 3.54, 4.55, 5.5, 6, 6.5, 7, 7.5, 8, 8.5, 9, 9.5, 10 millimeters. Okay? Okay. Calipers have 2 legs at contact parts to measure them. Slide calipers are similar to rules. They measure internal or external dimensions. Outside calipers measure external dimensions only. Inside calipers measure internal dimensions only. Naturally, one's outside, the other one's in the inside. So it kind of helps you